Okay, so before starting the Bode plot, I want to explain the basic concepts of the Bode plot. So there are basically four important things to consider in the Bode plot. So one is gain, second is the S term. Okay, so third is S plus any value, let's say 3 term, and the fourth is a quadratic term, so s square plus 10s plus 6. So it's just an example. So this is a quadratic term. So we will consider these four things to draw any Bode plot, right? So let's say we have an S term. S term means that if we have a transfer function and we have an s in the denominator. So if we have an s in the denominator, so all we have to do is just draw a straight line from minus infinity to plus infinity, and this line must cross 1. So we have 1 here, we have 10, we then have 100, similarly we have 0.1. So a straight line going from minus infinity to plus infinity, right? So and this line will be minus 20 dB per decade, so this point must be 20, and then at this 10 this line must be here at minus 20 dB, right? So if it's a pole, a single pole, then we have to draw this single line. But if it's a single zero here, so we will draw a line from minus infinity to plus infinity, but this time the slope will be plus 20 dB per decade, right? Okay, this was minus 20 dB per decade. Now if this s is s square, okay, so if it's s square, then everything will remain same. But as it's a pole, so this line was for a single pole, this was for a single pole, but now it's two poles, so what we have to do is just make it 40 dB per decade, right? So we will go it like this, so minus 40 dB, so this line will then be at minus 40 dB per decade, and it must cross this 1. Okay, so if it's 1 here, then at the previous decade it must be at 40, and at next decade this must be at minus 40, right? So this is the basic concept here. So now if this s square is in the numerator, so we have to draw this as 40 dB per decade and this as 40 dB. For 0 we go plus 20 plus 40, and for poles we go as minus 20 and minus 40. So this is how we handle the s term. So this second thing is the s plus 3 term, like s plus a we can say. So in this case all we have to do is first find the break frequency. So the break frequency is fine. We can find the break frequency by taking, like, we have to make this s plus 3 term as s plus 1. Okay, so how can we make this term as s plus 1? If we take this 3 common, so it will become s plus 1, right? So it will be s by 3 plus 1. Okay, and we took this 3 common. This 3 will be the part of the gain k, so I will explain this later, but this will now become s plus 3. So we need this type of form. If ever we are given with, let's say, s plus 10, so what we have to do is simply take the 10 common, so it will be s by 10 plus 1, right? So this 10 will move to gain, the part of gain. I will explain it later how we can manage that. So this term will be my break frequency. Okay, so this will be my break frequency, right? So now let's suppose one more example. So I try to cover each and every case. So let's say we are given with 2s plus 5. Now remember that this s must also be a single s. There must not be any constant with it. So we just have to first take these 2 common out. So it will be s plus 5 by 2, and then we can take out this 5 by 2. because we have to make one here also, and we should make one here as well. So if we take out this 5 by 2 along with these two, it will become s plus 1, right? So now we can start plotting it, and this term will be the part of the gain k, and now we can plot this, and we know that here is now, because we took this 5 by 2 out, so there will be 2 by 5, right? Because we took this 5 by 2 out. Okay, so this will be now our break frequency. So how can we handle this thing? So we can handle this like, suppose we have s plus 5 and this become s by 5 plus 1, and it's in the denominator, so it's a pole. So just remember that if it's in the denominator, it will be a pole, and we will have a negative slope. And for the 0, it's exactly the same thing, but will be the positive slope. So if it's minus 24 pole, then it will be plus 24 0, right? So the break frequency here is 5. So all we have to do is keep the plot 0, keep the line 0 till 5. Okay, so if 1 is here, 10 is here, then 5 must be like here, and it should go on. If it's a pole, it should go on like minus 20 dB per decade, and its decade does not ends at 10, because it starts from 5, so its decade will be till 50, right? Because the center of 10 and 100 is 50, right? So at this point, this line must reach minus 20 dB, because it's a single, its multiplicity is single, it's a single pole, so it must be minus 20. If it was a 0, then it must have been like this, and here at 50 it should reach 20 dB. Okay, so this is how we handle this s term. So for s plus a term, so for s term we have seen that it must be from minus infinity to plus infinity, and this line must cross 1. But for s plus a term, we have to keep the line straight until we hit the break frequency, and when we hit the break frequency, we go either up or down depending upon it's a 0 or a pole, right? So this is how we handle the s term. The third thing is the quadratic term. So s square plus 5s plus 10. One more thing is that, let's say if we have this s plus 5 whole square, then it's also the s term, but there is a square in it, right? So we can either make it as quadratic term, and we can also take it as this s term. So we have to just increase the multiplicity, because it was a single pole. So for a single pole it was minus 20 dB per decade, and for two poles, now there are two poles at minus 5, so we'll make it minus 40 dB per decade and plus 44 0. So rest will remain same, right? Now for this quadratic term, what we have to do is make one here, just like we have done in this case. We took the 3 out and we say s by 3 plus 1, so we made one here. So now we should make one here, right? And we also should make one here. So also remember this thing, because it's important. Sometimes teachers give questions like, and we have a coefficients here, so the value does not comes out to be the same if you take it as it is. So you have to take this 10 common, and if there is something else, if at this here, if there is a coefficient, you need to take it that as well. So if you take that 10 out, so it will be s square by 10 plus 5s plus 1, right? Okay, there should be 10 as well. So we don't need to look at this thing, because what's important is the break frequency. We want to find the break frequency. So as here it's an s square, so at the denominator we will also have omega square. So in this case it was s, so we have just s over omega, and we said that our break frequency is 3, right? But this time, as it's an s square, so we have omega square in the denominator, right? So omega square is equals to 10, and omega will definitely be under root 10. So our break frequency is under root 10, right? So we have to look at this thing as well. So because this was a quadratic term, right? So it's two poles. So if there are two poles, so obviously the multiplicity is 2. If multiplicity is 2, then if it's a pole, we will have minus 40 dB per decade, and if it's a 0, we will have plus 20 dB per decade. And as this break frequency is under root 10, so the concept is same for s plus a term. We have to keep things simple, straight 0 till under root 10, and once we reach under root 10, if it's a pole, we have to go down, but this time minus 40 dB, because it's a second order pole, right? Quadratic term, we have two poles, so it will be minus 40 dB per decade, and here it will be plus 40 dB per decade for 0. If there is no 0, then this line should not be drawn. Now I guess I have explained all the basic concepts, so that will be required. Now I should start solving this example based on all these concepts. Okay, so let me create a new file. So the question was 10 s square plus under the root 12 10 s s plus 100 divided by s plus 10 power 4. Okay, so the first step is, as I didn't explain how to handle the gain k, so I will explain it here. So the first thing is that we have to make the gain k, and we have to make this all s and s plus s over omega plus 1 and s square over omega square. We have to make all of the things in this form that I have explained, right? So we must make 1 here, we must make 1 here, we must make 1 here, and we must make 1 here, right? And we also should make 1 here. Okay, so let's take this 100 out. So if I take this 100 out, then we will have 10 as it was before in the numerator, and we will have 100 here. Also we will have s squared divided by 100 plus under the root 12 10 divided by 100 s plus 1. So we have made 1 here, so right, it's now in the form of our break frequency. So let me just resize it. So it's already, I guess, resized. Okay, so now we can see our break frequency is omega square is equals to 100, so the break frequency is omega is equals to 10. So that's okay, but let us first write it all as in the form I have described. So this 10 here should be 1. I told you that here should be 1. So this 10 power 4, we should take this common, so it will be 10 power 4, and it's already 1 here. S plus 1, but here must be 10 power 4. So now this is exactly in the form that I have explained you. So I have explained that there must be 1, here must be 1, here must be 1, here must be 1, and here must be 1, right? So we have to make a value of gain k from this whole term. Okay, now this term will be handled exactly the same way that I have described. So I will draw now that how can we make it. But first, this term, we have to multiply these two, so it will be 1000, and 1000 divided by 10 power 4 turns out to be 0.1. So this is our gain k. So k is equals to 0.1, but we are on the scale of dB, so we will take 20 log of k is equals to, so k is 0.1, so 20 log of 0.1 is minus 20, right? So whatever value it comes out to be, whatever the value calculated here from this coefficient, let's say if it was plus 30, so whatever value we get, what we need to do is start our axis from that point. So if so our value in this case is minus 20, so we should write minus 20 at the origin. So it just decides the value of the origin, this gain k. So if our answer was 13, then we should write here as 30, right? But now and if it's 13, we also should, on the axis, we should make this as plus 20 plus 30. So if this is 33, then this will be 33, right? So this will be 53, this will be 73. Similarly, this will be minus 20 less than this will be minus 70. We should draw axis like this. So it's just depend upon the axis. It just decide the axis, this value. So if it is 13, we should make it like this. But this time it is not 30, so we should make it according to this question, because I'm solving this question, right? So my origin will be at minus 20. So if it's minus 20 here, then obviously it will be 0 here, and then 20 here, 20 gap, we should 40 here, 60 here, and we can go up there how much we can get. So it will be minus 40 here, then minus 60, then minus 80, right? So, and we can start from any point. So considering that our break frequency must lie on the axis, so what were our break frequency? So one break frequency is 10 power 4, so we have to make our axis like this, like in such a way that we get this 10 power 4 in our axis, right? The another break frequency is 10, so we have omega 1 is equals to 10, omega 2 is equals to 10 power 4, and this one is the pole at origin, so it is, you know, omega 3 is equals to 1, right? And this 10 power 4 has multiplicity 2, so its like its slope will be minus 40 dB per decade, because it's a pole, right? So sorry, it's S1, its multiplicity is 1, but this 0 has the multiplicity of 2, so we can write it that n is equals to 2, and its slope will be, as it's a 0, so its slope will be plus 40 dB per decade, right? Plus 40 dB per decade, right? So now if this is the case, so we have find the 3 break frequency, but we should draw the 3 lines. So as there are 3 break frequencies, so we'll draw 3 lines based on the concept that I have provided. So this omega 3 is the pole at the origin, and for the origin we have a concept that, so first we have to draw these x-axis. Here let's say it's 1, then it's 10, then it's 100, then it's 1000, then it's 10 power 4, 10 power 5, right? So we have included all the break frequencies. So our break frequencies will all be included in this, because our break frequencies are 10 power 4, 10 and 1, so all lies here. So we should draw the axis like this. So we can start it from 0.1, 1, 10, so it's our choice depending upon what are our break frequencies. So let's just, based on the concept that I provided, let's just draw the first line. So omega 3 is a pole at the origin, and its multiplicity is 1, right? Its power is 1, its multiplicity is 1, so it must be minus 20 dB per decade, and the line must cross this. So its decade must be here. So this is the first decade, this is the first decade, right? So it should move minus 20 dB between this decade, right? So its decade, this is 20 dB slope, minus 20 dB, then again we should go minus 20 dB slope, then minus 20 dB, and that's all, right? So this slope should be like this, minus 20 dB per decade. Okay, second line, the second line will be, we have the break frequency of 10, okay, and this 10 break frequency is in the form of quadratic, so it will be plus 40 dB per decade, and it's a 0, right? So the concept that I have provided was that you have to keep everything straight 0 until you hit break frequency. So we hit break frequency here 10, and we should move on like per decade. So its decade starts from 10, so its decade will end at 100, right? So if it was started at 50, then it must end at 500, but it starts from 10, so it will end at 100. So in this particular distance it should cover 40 dBs. So it should cover 40 dBs, right? And similarly it will go on like this. So it's the second line. So now we have to draw the third line. It was 0, so we draw it as positive, so plus 40 dB per decade, right? And the other line was minus 20 dB per decade. Now we have to handle this other thing, and this thing is its break frequency is omega 2 at 10 power 4. So we have to keep things 0 until we hit the break frequency. That this was the concept for S plus A term. Now it's you just decide if it's a 0 or a pole. So it's a pole, right? So we have to move on minus 20 dB per decade. So its decade ends here, so it should make minus 20 dB here, and then it should move on. Now that's where we have drawn all the lines for all the poles. Now we just have to add these 3 lines. So if we add these 3 lines, our Bode plot will be completed, right? So we have handled the gain k. I told you that it just decides the axis, and then we also have handled the S term, the S plus A term, the quadratic term. So we just have to now add these terms. So till 10, till this point, we only have a single line, right? So we only have a single line which is minus 10 dB per decade. So we have to draw the same thing again, exactly same thing, right? So we can again draw this 10, 100, 1k, 10k, or 10 power 4, 100k, right? And we can then write there was our 0, no, here it was minus 20, then 0, then 20, then 40, then minus 40, minus 60, minus 80. Okay, so we have to add them graphically, right? So till 10 we just have a single slope which is coming from minus infinity till this 40 point, till this 40 point, and till 10, right? So what we have to do is we have a single line which is coming from minus infinity, which crosses 1 and here. Until this point we have a single line, so we have drawn this, right? And its value was minus 20 dB per decade. But at 10 we have now two lines till, we have 2 lines till 10 power 4 where the third line started including. Okay, so at this point we have 2 lines. One slope is minus 20, other slope is plus 40, so it will be plus 20. So after this 10 we will have plus 20 dB per decade until we reach the third line. So we should keep going until we reach the third line, right? So let's go here. Now we should move on plus 20, because minus 20 plus 40 was 20. So plus 20 to dB per decade means that from here to here it should go 20. So that's it. Now from here to here it should go again 20. It should go again 20. It should go again 20. So sorry, this was the point of 10 power 4, I guess, right? So it should not go onwards the same. It should only reach this one, right? So this, now the contribution of the third term must also be included, because at 10 power 4 we have another break frequency, right? And at that 10 power 4 we have minus 20 dB per decade line, because it was a single pole. We have this omega is equals to 10 10 power 4, a single pole. So we'll have minus 20 dB per decade, right? So this line was minus 20 plus 40 is equals to 20. So this line was 20 dB per decade. And if 20 is 20, after this we have 3 lines. So minus 20 plus 40 was 20, and the third line is minus 20. So plus 20 minus 20 will become 0 dB. So it should stay 0 after all. Okay, so if it was, let's say, 40 and then we subtracted minus 20, then it should go on like minus 20 from there. So we should just add them graphically, like at first we have just minus 20 dB per decade line till 10. So we have drawn that. After that we have 2 lines, one is minus 20, other is 40. So the contribution is plus 20. So we have drawn plus 20 till the third line, and the third line is then minus 20. So plus 20 minus 20 was 0. So we kept everything like this. So this is our final Bode plot for this. So this is the Bode magnitude plot. So it's a magnitude plot, and for the phase plot I will upload another video, and you can ask any question if you don't understand anything in this, because I tried to explain each and every step, but still if you have any question you can ask. And the second thing that I wanted to mention is, let's say if the break frequency was at 15 here, right? If it was at 15, then it should reach till 15 here, and remember that the break frequency will be 150 now here. The decade will complete at 150. As it was an easy question that I have solved, the decade would start at 10 and 100. But if it was at middle, then it must go from this point onwards to this. So if it is here and this value is 45, and it should go for its decade complete at this 150, right? So at 150 it should move from this point to this point minus 20 dB. So minus plus 20, right? So plus 20 means it must be 25. So this at this point, right? So from 15 to 150, this line must travel from minus 45 to 25. So it's a bit complex thing. So teacher usually don't ask such type of question, but on graph paper you should know that from where your break frequency start and where it should complete till for 20 dB. So it will not be always the case that it should 1 to 10 it should go 20 dB. It can be from 3 to 30 it should go till 20 dB, and maybe the line ends at minus 45, just like, because this line, if our break frequency was 15, then it should not end at minus 40, right? So because it should go on till minus 15, so it may be minus 43. So if it's minus 43 and after that if it go 20 dB, then it will be at 23 till 150, right? So that's the thing that I wanted to explain also, because sometimes such type of questions comes in the exam. So that's all from this. If you have any question, kindly ask.